But yeah, we're going to try to hopefully make sure that they know what's up with everything too, because most of what I've done as Gavin and Quinn have been gone, I have just like put the worksheets up there and they figured it out with no big deal. Today's, while it's not in any way hard, it is different. And so, you do need to know what you're doing with it. So far, when we have talked about quadratic equations, what we have done is factor to find answers. And that's what you did on this last test. You factored stuff into nice, neat factors, and the opposite of that ended up being your answers. However, obvious questions will come up like, what if you can't factor? Or what if you found this to be like the most annoying thing we've done all year and you don't want to do that? Well, what we're going to talk about next is other ways that you can solve quadratic equations. And we're actually going to learn two other ways. Today, we're going to talk about one that's fairly easy once you get it. And it works on many problems. It would actually work on anything you could factor, among other stuff. But we're going to learn yet another one that we'll talk about after that will literally cover everything. And so what I want to do is talk about how we might solve these problems. And then we're going to go into some other stuff with these. Now, these are all quadratic equations. They're written a little bit differently than the ones that were like on the third page of your test because these already have like something squared in them. And like on that first one, if you wanted to, you could like multiply out all the stuff on the left and then get everything on one side and then factor it. And it would be like an even harder version of the last problem on the test. However, there's a much easier way to do this, and there's also easy ways to do the other two, which we'll talk about as well. You all agree that these all say something squared on the left-hand side, right? Well, in algebra, you can always do opposites to get answers. What's the opposite of square? Square root. Yeah, square root is definitely the opposite of square, and that's what we're going to do to solve these, is we're going to take the square root on both sides. And when you do that, you want to remember that when you take a square root, you always get two answers. You get like a positive answer and a negative answer when you do square roots. And that's how, like on all of the ones you had on the worksheets and tests we've done recently, we're going to end up with two possible answers to these. So if I wanted to do this, what I'm going to do is take the square root on the left and the square root on the right. You tell me, what's the square root of 81? Yeah, and technically it's 9 or negative 9. It could be either of those numbers. So what I basically have is x plus 7 equals either positive or negative 9. You guys all see where I'm getting that from. So what I really have to do here is I've got to solve two separate problems, and they're both like the easiest problems ever to solve. I've got to solve x plus 7 equals 9 and x plus 7 equals negative 9. And, I saw some problems a lot like this on the copier from one of the elementary teachers earlier this week. Hopefully, like the first answer is going to, I believe, end up being 2, right? What's the other answer? Yeah, because you just subtract 7 both times, and those are our answers. Now, you could have, like I said, multiplied everything out, gotten it all on one side, and this would have actually factored into x minus 2 times x plus 16, but I'm betting you probably wouldn't have wanted to do those factors. But taking the square root and then getting x by itself is actually a pretty easy way to do that. And that is a method that will often be the easiest way to solve problems. And we can even do it when you have problems like this where the square root isn't anything nice. In fact, it's almost easier. So here I have x minus 2 squared equals 13. Well, if I take the square root on both sides, I'm pretty sure it's going to look like this. X minus 2 equals plus or minus the square root of 13. And the square root of 13 is nothing special. It's like 3 point something, but it's the square root of 13. I'm just going to leave it that way because I don't need a decimal. I'm going to write something that's easy to write. Would you agree I've got to add 2 to get x by itself? So that's what I'm going to write as my answer. If, like, I had a reason where I needed to know what that is as a decimal, I'd haul out my calculator and I'd take square root of 13 plus 2, and then negative square root of 13 plus 2, and I'd have my answers. You okay with that? And I can also do that with something like this. It's not in any way a hard problem to do, but I've got to think a little bit more carefully on this one. So again, I'm going to take square root on both sides. I'm pretty sure on the left it's going to say x plus 5. Who knows what the square root of negative 9 is? I don't know, we might have done back around Christmas time. I'm pretty sure when you take square roots of negative numbers, that's when you start getting I in your answer. And all I do is I take the square root of 9, which is 3, and because it was negative, I toss in I. Back when we did that chapter on complex numbers, those were supposed to be the easy questions. When you did those, you just did the square root of whatever, and you toss in I because it's negative. And I would probably write the answer in this one as plus or minus 3i, and then I just put minus 5 like I did in all the other ones. A book will almost always write negative 5 plus or minus 3i. They're just going back to like when we first did complex numbers, they put the real part first and then the imaginary part, but it's okay either way. Okay. Any big deal with how that's working? So again, we're just taking the square root and getting x by itself. That's really the key thing there. And so anytime that you can make something say something squared equals a number, that's how you get the answer. Okay with that? Not quite done with the notes, but that's the key to what we've got for our notes today. So now we're going to take a look at a problem kind of like this thing, where it says x squared plus 8x equals 17. Which looks kind of like that very last problem on the test, although I will tell you, if you tried to move the 17 over to the other side and factor it, there's no way you're going to factor that, because nothing that goes into 17 is going to add up to 8. But there's still an answer. That doesn't mean that it's not going to work out. It just means the answers are not nice even numbers like they were for most of the stuff that you were doing on your test. So what we're going to do instead is we're going to use a method that's called completing the square. By now, you should know that almost anything that you do in algebra, your goal is to make it look like something easy to solve. Yeah, that's when you were first solving equations. You learned easy equations, and when they came hard, you made them look like easy equations. Well, what I'm going to do here is I'm going to make this look like those problems we just got done doing. I'm going to make this say something squared equals a number, and then I can do it. And it's actually pretty easy to do that. What I want to do is I look at this number, and I think, gee, what would I have to add on to this to make this a perfect square like what we had before? And it turns out that what I'm going to do is I am going to add 16 to both sides of the equation. Now, there's a real easy way to get that 16, and I'll tell you that officially in a minute. But if you look at the left-hand side of this, I could have actually asked you that very question on the test yesterday, and it would have been one of the ones that just had like one blank on it instead of two, because this would factor into x plus 4 times x plus 4. It is actually x plus 4 squared. Whatever I do to one side, I've got to do to the other. That's why I put plus 16 on both sides. And suddenly, what I've got is pretty much the exact same thing we just got done doing. Okay. Who knows what we would put for an answer this time? Or what would you do like after you do the square roots on this? What's the left side going to say when you do the square root? Yeah. X plus 4. So I think it's going to be like x plus 4 equals square root of 33, right? And again, always plus or minus. And that's why my final answer is just going to be plus or minus square root of 33 minus 4. Everybody follow that okay. We're going to look at two other quick examples, but I'm going to say in general, what you do is this. You look at the problem. You always take half the number that's by x, you square that, and you add it to both sides. So like in the problem we just did, it said 8x. What's half of 8? 4. And if you do 4 squared, I'm pretty sure you get 16, right? So that's why I added 16 to both sides. I take half of whatever's by x, I square it, and I add it to both sides. When you do that, it guarantees you're going to get a nice little perfect square like x plus 4 squared. And what you always get is x plus half of whatever was by x originally, quantity squared. That's what it'll always end up being. You write it as a perfect square and you solve it just like the ones we just did. So again, we're going to look real quickly at two other examples today and see how those go. And the first one will end up being this one, x squared minus 6x equals 5. Who knows what I'm going to have to add on both sides this time? 9 is right, because we've got to do half of negative 6 is like negative 3, square that, and it's going to be 9. It's always going to be a positive number you add to both sides, because when you square stuff, it always becomes positive, okay? So I want to add 9, which I'm pretty sure is going to end up giving me something that looks like this. That makes sense to everybody. And we'll look at one more, well, I already advanced this. I had x squared minus 4x equals negative 5. Does it make sense that I've got to add 4? I'm seeing a bunch of nods, and that's a good thing. So that's because half of that is going to give me negative 2. I square that, I get 4. And so I add 4 to both sides, which, if I do that, I'm pretty sure is going to give me negative 1. What's the square root of negative 1? Say it again. 1i, absolutely. Yeah, I purposely threw in a couple of I ones just to remind you of where things were from before. What we're going to end up getting on this one is basically like plus or minus I plus 2. Again, the way we solve all of them is you look at that number by x, you take half of it, you square it, and that's what you have to add on both sides. You get a nice square equals whatever the number is, do the square root, and move your number over. It's pretty much all that you do to solve the whole thing. Questions with that at all? Problems with those? So I'm going to tell you, we're actually going to do the problems over this tomorrow. We're going to wait until then to do it, and we will take a look at a worksheet on this tomorrow, but today we're going to leave the notes and let them hopefully sink in a little bit and go from there. But that's the next key step. So we'll leave it there and go on.